Welcome all. Today's class is about projection of solids. We can discuss two problems in projection of solids. Both problems are coming under the category of general cases of solids inclined to HP. First question is general cases of solids inclined to HP, and the second one is solids inclined to VP. These are the two different categories of solids we are discussing in this particular class. Then for the reference, we are already discussed these dimensional parameters of different solids. This top face, base, rectangular face, long edge, etc. in the case of square prism. Then in the case of square pyramid, slant edges, apex, triangular face, then base, etc. And in the case of cone and cylinders, there is generators, and that generators are the imaginary lines generating curved surface of the cylinder and cone. Then we have discussed various types of solids, truncated solids, then frustum of a cone, frustum of a pyramid, etc. Then in this particular problem, we will look into the projection of solids, that in which solids are inclined to particular reference planes. First problem, a square pyramid 40 mm sides and axis 60 mm long has a triangular face on the ground. Draw its projections. Its triangular faces is on the ground. A square prism resting on ground or HP in such a way that its triangular face is on the ground. Here, while we observing this particular solid, a square pyramid, we can see that these are the triangular faces. Triangular faces are the slant faces, triangular faces, and the base is for a square pyramid, that base is square. Base is a square, and the side views or side faces are always triangular faces. Triangular faces. Then, when that particular object is resting on the triangular faces on the ground, we can first draw the top view of the square pyramid. An XY line, then top view of the square pyramid. For preparing a square pyramid, we have to draw a square like this. Then we can select two types of squares. First one like this, in which the sides are parallel to XY line. Other one is like this. We can draw square like this also. But if we choose this particular square as the first or base figure, then we can see that these straight lines in front view actually representing the triangular face. This triangular face. This triangular face. This triangular face in top view can be represented in front view as a straight line. While we choosing this particular square as the base figure, we can see that this line is actually the slant height. This particular slant height is represented as a straight line in front view. Then, if a square pyramid resting on its triangular face on the ground, then first figure, base figure must be like this. Then we can draw the slant heights. In order to represent the pyramid, we must represent the slant height. Otherwise, that figure will represent a prism. Without this slant height, we can represent a square like this, but that figure is the actual representation of a square prism. Then in the case of square pyramid, there must be slant height. Or in the case of any pyramid, there must be slant heights. Then we can name it as A, B, C, D like this. Then O and P, this particular axis point. Then if we project this A and B base to XY line, then C and D also to XY line, then we can name this particular point as B dash in bracket A dash. That means in front view, this is the front view. Then in front view, we can see point B. We can see point B, but we can't see point A. Then A dash must be in bracket. A dash must be in bracket. Similarly, at this point, we can represent C dash in bracket D dash. C dash in bracket D dash. Then we can project this axis point also. Then this point will become P dash, and this point will become O dash. Axis height is given as 60 mm axis height and 40 mm base. That means the length of this base side is equal to 40 mm, and axis height O dash P dash is the axis, and that O dash P dash must be equal to 60 mm. O dash P dash must be equal to 60 mm. Then we can represent that axis by using a chain line. Then we can complete the square pyramid. Okay. Then if the condition is the triangular face is on HP, then in its front view, this particular line, this is the front view of this particular triangular face CDO. Triangular face CDO can be represented as C dash, D dash, O dash in front view. Otherwise, in top view, we can see axis point O, but we can't see the axis point P. So that we can represent this point as O in bracket P. Then this particular straight line, actually that particular straight line is the front view of the triangular face CDO. This triangular face is this one, C dash, D dash, O dash. Then if we rotate this front view in such a way that O dash, C dash, D dash on XY line, that means that triangular face is on HP. That triangular face is on ground. So that we can represent that triangular face in XY line like this: C1 dash, D1 dash, and this point is O1 dash. Then we can recreate this particular front view, this shape in this secondary view by utilizing this angle. This angle is equal to, if we treat this angle as theta, then that theta is the angle between the base and this particular triangular face. And this particular triangular face is already represented as C1 dash, D1 dash, O1 dash in the secondary figure. Then we can transfer this theta from this figure to this figure. Here this angle is equal to theta. Then we can draw the base, length of this base. Then we can represent C dash, D dash, P dash, this small distance. Then we can represent that P1 dash here. Then length C dash, B dash, that length is equal to this base edge length. Then we can complete the front view. Then we can complete the secondary front view. All the points are marked as per the dimensions given in the base figure. Then we can project it and find out the final view of the solid. In top view, this they find out the intersecting point of A1 dash and A1 dash from the projection line which is passing through A1 dash and a projection line which is passing through A. That intersecting point will become A1. Similarly, B1, we can locate B1, C1, then D1. D1 is the meeting point of the projectors passing through D and D1 dash. Then we can locate P1, the axis point. This point will become O1. This point will become O1. Then in the next step, we can create the final top view. And for that purpose, there are 2 or 3 types of theories to locate the visible edges. In which first one is the outermost edges of the solid always thick line. That is the first condition. Outermost edges of the solid always thick line. Here, outermost edges means A1 O1, O1 B1, B1 C1, C1 D1, D1 A1. That is outermost edges. That edges must be in thick line. In the first step, that lines, that outermost edges always thick line. Then in top view, here A, B, C, D, all corners are visible. In top view, A, B, C, D, this visual ray will touch all the points A, B, C, D. All points are visible, so that A, B, C, D, that a rectangle in the secondary top view must be thick line, in thick line. That means that base part is completely visible. Then next, in top view, slant height C dash O dash is not visible. C dash O dash is not visible. Similarly, D dash O dash also not visible. That means C1 O1 and D1 O1 both are in broken line, because that edges are not visible in the top view. Edges are not visible in the top view. So we can represent that edges as broken line. Then all the edges are, we have already marked all the edges. Here edges AB, BC, CD and AD. All edges are completed. Then AO, BO, CO, DO. These are the slant heights. Then A1 O1, B1 O1, C1 O1, D1 O1. All slant heights are already completed. That means entire figure is completed. But we have to represent that axis also, P1, O1 also. That axis must be in chain line. Then that is the final figure. And this is the final solution of this particular problem. Thank you all.